Hi everyone, in this video I'm continuing to take a look at question 7 part A of the 4-unit HSC exam from the year 2000. So here I'm going to be focusing on part 2, which follows directly on from part 1. So if you haven't had a look at my video there, definitely take a look, I'll provide a link. Part 2 says, from part 1, deduce that the sum from I is equal to 1 to n of xi log yi on xi will be less than or equal to 0. And then we're given these conditions, so that's going to be true whenever the sum from I is equal to 1 to n of xi is equal to the sum from I equals 1 to n of yi is equal to 1, where xi is positive and yi is positive for I is equal to 1 and 2 and so on up to n. And then we also want to show that equality occurs only if xi is equal to yi for those values of I. So let's take a look. I've written up all the information given in this question. The basic requirement is to deduce this result using part 1, and then we've got all our other conditions. Now, I think the key is, we're told very specifically use part 1, and if you take a look at part 1, it's kind of, you can kind of see the link. We've got this log x, and we've got this inequality. And here we've got a log of something and an inequality. So you can kind of see how, as long as we define, I guess in this case, what x should be, I think we're going to get there without too much trouble. But I think the trick here is, how do you define x? And because here we've got xi's and yi's, I think it might not leap out immediately. But I actually think if we let x be defined as yi on xi, then basically what we're going to get is basically from part 1, it would be the case that the log of x, or in our case the log of yi on xi, would be less than or equal to x minus 1, or in our case it would be less than or equal to yi on xi minus 1. And that's going to be for, well, in part 1 it was for x greater than 0, but we've defined x as this, so it'll be for yi on xi greater than 0, and that's going to be fine, because if xi is positive and yi is positive, then yi on xi will be positive, so that's okay. And it would also be with equality at, well, again, in part 1 it was with equality at x is equal to 1, but here it will be equality at yi on xi is equal to 1, which actually means if we bring the xi up, xi equals yi. And that's one of the bits we had to show. So we've kind of done this bit pretty quickly. And again, it all came down to strategically picking how to define x. So we've got this bit of the question done, but now we need to do the main bit, which is showing this inequality. And I think we just need to do a bit of rearranging and we'll get there. So maybe what we'll do is we'll say, therefore, the log of yi on xi will be less than or equal to, and let's get a common denominator here. So it's going to be yi minus xi on xi. And that's looking pretty good, because we've got a log yi on xi in our result, and we've got that here. And then we've got an xi, which we can get quite easily by just bringing this up. So let's do that. So we can say, therefore, xi log yi on xi will be less than or equal to yi minus xi. And now, really, we know we're working towards a 0 on this right-hand side, and this is probably going to help us get there. But actually, before we even get to that point, we need some summations. But it's totally valid to take the sum of both sides. That's something you can do without affecting your inequality. So we can say, therefore, the sum from I is equal to 1 to n of xi log yi on xi will be less than or equal to the sum from I is equal to 1 to n of yi minus xi. And that's going to be therefore less than or equal to, and we can do the sum over each part. So it'll be the sum from I equals 1 to n of yi minus the sum from I is equal to 1 to n of xi. And as I hinted at, this condition becomes completely relevant because we're trying to show that this inequality is true only when these sums are equal, and specifically equal to 1. So essentially we're then going to get this being less than or equal to 1 minus 1, or in other words, less than or equal to 0. And there we've got our result. This left-hand side is what we wanted on the left, and 0 is what we wanted on the right. And we already showed equality happening at xi equals yi. So yeah, from part 1, the key to this question was simply defining x. And I suppose it takes a bit of practice and maybe a bit of comfort with thinking of something like defining x as yi on xi. I think the hint is, we were told to use part 1, and in part 1 we had a log x. In this question we have a log of yi on xi. So just take the log of x and make it instead log of yi on xi. In other words, x is y on xi. And then you just got to be careful with your algebra. So hopefully that all made perfect sense and it's easy enough for you to follow along with. And now in the next video I'm going to work through part 3 of this question. Alright, tick boom.